Okay, 8M6, Lesson 3, Representations of a Line. We are continuing on with stuff we've done before. We're just taking it and making it more applicable and more real-world example-like. So we're going to start today with, again, stuff you've learned before, but we're going to start with verbal models, and we're going to be focused on creating graphs out of them and then making decisions and answering questions based on the data in those graphs, making estimates and exact calculations. In some cases, we'll be creating formulas, and in some algebraic equations. In some cases, we'll be using T-charts to help us understand what we're doing. But pretty much, we're going to be taking verbal models, which are word problems, putting them onto graphs, and then answering questions. Now, today's lesson is going to be a little different than in past lessons I've done, in that I really think that the examples they gave in the book today are great examples, and I'm going to go over the 3 examples from 8M6 Lesson 3 that you did in class today. So if you totally understand them, you totally get them, you may not get anything out of this lesson. But if you want to review what you did in class, you missed class, or maybe you didn't understand what happened in class because you were tired, or want to understand it better, or maybe you want to have your mom or dad watch it, those are all reasons that this video might be good for you. So let's go forth and let's just go over what was done in class today. So again, in class, in the handouts, you did 3 examples, and we're going to go over those 3 examples right now. 3 examples from class, and in all cases, you had a verbal model, which is another word for a wow, what's wrong with my writing? Word problem, word problems, and then you convert that into graphs. And then in some cases, you might need to make an equation or a T-chart out of that data. But for the most part, we're building a graph, and then we're going to interpret the graph. Okay? Because graphs are good visual ways of understanding information that can't always be easily gleaned from word problems or verbal models. And that's why we bother building graphs, and why you will see graphs in newspapers and in publications and in PowerPoint presentations, because they're easy for eyes to grasp information. But it's important that as we get in 8th grade and we head into high school, that we understand how to read graphs and how to discern information, and how to go one step beyond what graphs, what information, and learn and see what extra information is held inside graphs that aren't always apparent to the casual observer's eye, because we're mathematicians and we're doing algebra, and we are becoming very smart at math. So let's move forward and let's look at these 3 examples that we did in class today. Okay. So this is example number 1, and I'm going to call all of this homework help, because everything we're doing, and this is example number 1, because everything we're doing here in this video applies directly to the homework examples. Okay, so in this example, you are going to rent a truck, presumably because you're moving, and so there's a $100 rental fee that you have to pay. $100, you know, $150 rental fee. And then you also have to pay 50 cents for every mile you drive. So if you drive 1 mile or 100 miles or 1,000 miles, you have to pay this $150 fee, plus, you know, well, let me just make it a normal plus sign, plus 50 cents or half a dollar, $0.5 per every mile, per mile. Now, let's examine this in terms of what we learned in 8M4 and in 8M5. And we know also today that this is a linear equation, because it tells us this is a linear function. And so when we think linear function, we're thinking what? Y equals, say it with me, mx plus b. And we're thinking that this m is our slope or our rate, and our B is our fixed or our starting amount, AMT. Okay, M is our slope, and B is our fixed or our starting amount. So let's see if we can figure out the keys here that are going to tell us how much it's going to cost in total. So the total cost is our Y. So this is our Y, and our miles driven is our X. Okay. So we're saying our cost is equal to our slope times X, where that's miles, plus the starting amount. So the starting amount is also represented by what happens if we drive 0 miles. So if we drive 0 miles, how much is it going to cost us? Well, we know that if we drive no miles, this fee is going to be 0, but we still have to pay this $150 rental fee. So if we drive 0 miles, it's going to be $150. And so that's represented 0 miles and 150. So that's kind of our X, or that is our X, and that's our Y, or our, in this case, it's our M and our C, but it's still X and Y. So this is this point here is, I don't know why I put this little point here because it's not right. We need to instead draw a point at 0, 150, because 0 miles will cost $150. Okay. Now, that being our B, we can just go ahead over here and let's just float this 150. Let's just put it over here because we know that that's our B, our starting point. Now we got to think about our slope. And that also relates to question B. What is the rate of change? And we know from previous lessons, rate of change, that's another word for slope. Right? So, and the other thing that we find, the other keyword we like to look at when we talk about slope is this per thing. So when we see the word per, we're almost assured that that's where our slope lives. And so we get 0.5, $0.5 per mile. And that makes sense, right? Let's recall what else we've learned. The slope in this graph is going to be our Y units, and we've learned this prior. It's always your Y units over your X units. So your slope is going to be represented in dollars per mile. Your Y units is dollars, and your X unit is miles. So it's dollars per mile. And that's good. We see dollars per mile. So that makes sense that this is our slope given everything that we've learned. Okay, and it's positive. It's positive. So that means that this line is going to be going up and to the right. But can we now use our old strategy of going, up, our delta Y, go up 0.5 and over 1 and up 0.5 and over 1 and up 0.5 and over 1? Well, no, we can't really do that here to draw our line because we don't have, our units are too big here. We can't go up 0.5 and over. We don't really know what that looks like. So we have to use a different strategy. And we've done it before, but I'm going to explicitly say, let me just explicitly give you a little rule here. When you can't use delta Y over delta X, when you can't use slope to move 1 point at a time to draw a line. Right? If we had, let me be really clear here. If we had a line that looked like this, And we said that this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5. And we had our, our y-intercept was 1, and it was like this, y equals 2x plus 1. We could go up to over 1, up to over 1 to draw our line. We could do that because the 2 units is our slope, and we go up to over 1. But here we can't do that because our slope is 0.5 over 1, and we can't go up 0.5 over 1, up 0.5 over 1 because our units are too big on this axis. So we have to use another strategy. Hopefully that made sense to you. Let me erase all this real quick. Whoops, not that. And so we're going to use a different strategy. And the different strategy we're going to use is to just pull a different, we're going to calculate a point that's out here. And we've done that before. So let me show you how we do that. So we said one of our points, our x and our y, was 0, 150. So now let's calculate a point that would be like maybe here at 500. And let's find our y for that. And then we'll get a point somewhere in here, and then we can draw a nice line. Okay. So let's look at our slope. Remember, our slope is 0.5. So here's our function. So we say our y, or our cost. So y and cost and x and m are the same thing. So we say y is equal to 0.5 times x, which is 500, plus 150. So when x is 150, we're trying to figure out what is y. Well, we get 250. 0.5 of 500 is 250 plus 150, and so that's 400. So y is 400. So if we drive 500 miles, it's going to cost us $400. And we know this is linear because the problem tells us it's a linear function. So now we can go ahead and make our line. And it goes on forever. And we can start to answer questions. So again, we need to draw 2 points that make our line, and we found this one over here at 500, 400. We've actually noticed, to do this graph right, we've found our equation, we've built a t-chart. This is our equation. This is our verbal model. And we have our graph. We've done all 4. And all 4 of these are equivalent ways of looking at the same thing, depending upon what is the easiest way for you to answer a specific type of question. Okay, so let's look at this now. On the axis given, sketch the graph of the linear function that relates c to m. Well, we've already done that. Gosh, we already done that. Let's lay down our happy cats for these things here. And let's answer our last question. Write the equation of the linear function that, and we've already done that. We've even modeled our linear equation right here. So we've done all 3 things. We've sketched a graph, we've written the linear function, we've identified the slope, we've identified the y-intercept, we've defined all these things. Let me ask you one more question, a bonus question. So how far can I drive this truck if I only can spend $600? So give that a try. Can you answer that question? If I only have $600, about how far can I drive this truck? Well, the answer is, if I have 600, let's see how many miles that corresponds to? Well, it looks to me like it corresponds to about 900 miles. So about 900 miles. Maybe exactly 900, but all I can say, because it's a graph, is about 900, because graphs are usually not as precise. If I wanted to know exactly, I could plug 600 in here and do a calculation and figure out, 600 in here, and then calculate my mileage. And I could get an exact number. Okay, so let's move on to question number 2, and it's going to be a lot like number 1 with a few different questions. So this is a homework help. Number 2. In this case, we have Jenna, who bought a used car for $18,000. So that's right now times 0. She has been told that the value of the car is likely to decrease $2,500 for each year she owns the car. So let's look at that. I'm just going to make the T-chart right here. And let's say that we'll say, well, T is our X, and our Y is our V, our value of the car, right? Our value of the car is Y, and our number of years owned is T. Okay, so she just bought the car, and so that's kind of like the starting place. In year 0, it's $18,000. And we know that it decreases $2,500 for each year she owns the car. So let the value of car be V. Okay, good. So after a year, let's just start. What's the next logical thing to do? Let's just kind of estimate or calculate. After 1 year, the car is worth what? If it decreases in value by $2,500, it goes down $2,500. So it's now worth $15,500. Okay. And then after 2 years, it's gone down another $2,500. So we're kind of answering this question right here. And so you can figure out what that is. If it's gone down another $2,500, that's now $13,000. So we can graph those numbers. Let's just go ahead and now, let's go over here and graph them. 18,000. After 2 years, it's 13,000. After 1 year, it's 15,500. And notice it's a nice straight line, as it ought to be. Okay, so let's think about this. Let's now read the questions. What is the value of the car when T is 0? Show this point on the graph. Well, that's right here. That's our starting point. It's $18,000. She bought the car for $18,000. It's worth $18,000. It hasn't decreased in value yet. So what is the rate of change that V relates to T? Is it positive or negative? Well, you tell me. Is the car going up in value or down in value? Well, it's negative. It's got to be going down in value, because that's what it says. It decreases. It's minus $2,500 per year. What does that look like when this per thing? Yeah, for those of you who said that looks like a rate or a slope, you are right. Okay, and so it's negative. Decrease. The key word is decrease. That's how you can tell. And you can tell. You could also say I can tell by looking at by looking at the T-chart. Right? I can look at this T-chart here and see that the value is decreasing as my years are increasing. Okay, so now we need to find out when T equals 7. Well, when T equals 7, I've decreased by how much? I've decreased by 7 times 2,500. Right? I've gone down 2,500 7 times. So that's 17,500. So this car is only worth $500. Now it's only worth $500 after 7 years. So let's see. That would be 1, 2, 3. That'd be like right down here. So now let's just plot the points and then draw the line using our straight edge. Okay. Let's lay down. Happy cat, happy cat, happy cat, happy cat, happy cat, happy cat, happy cat. Write a linear function that models the relationship. Okay, so this is where we have to write y equals mx plus b. And remember, x is the same thing as t, and y is the same thing as v, because we're just using different variables here. So let's write that. Value equals our slope. What is our slope? Our slope is the thing that goes with the per. We're decreasing 2,500 per year, minus 2,500 times t, which is our x, plus b, our starting point. Well, our starting point is 18,000. And voila, you're learning now how to write linear equations given starting points and slopes, and how to identify the slope and how to identify the starting point. That's the whole goal of today's lesson. But remember, we've been doing this for 2 to 3 months. This might be a really easy lesson for some of you who have been paying very close attention. And this is powerful stuff. This can help you model, you know, how much your car is going to be worth, this very expensive investment that you're buying, how much it's going to be worth after a number of years. How much is the car going to be worth after 4 years? Well, it's after 4 years, this is our point. Well, how much is your car worth after 4 years? Well, our car's worth about $8,000 after 4 years. After 5 years, it's decreased down to about $5,500. Right? So we can make some very powerful decisions and very powerful calculations knowing how to read verbal models. Now let's move on to the last question. This one's a little different in that it doesn't give you a starting point. There's no starting point. There's no starting point given. So in this case, we're going to be given some ordered pairs, and we want to identify the ordered pairs. Let me make this a little bit bigger. I don't know if you can read this. This is the same words as that are in the book. So if you have your book there, your handouts, you can read along. But you need to identify the ordered pairs in the problem and then plot them on the graph. And then we can draw a line because we know that this is a linear equation. We've been told this is a linear equation, so we know it's a straight line. Okay, the price. So if we need ordered pairs, we need to find some combinations of price and copies. So price is our x, and this is our y. So we need to find some ordered pairs that have a price and then a number of copies. That's our x, and that's our y. So do you see any examples? Yes. At $15, we have 800 copies. If any of you want to pause and try, I encourage you to pause plus try. You know, if you didn't go to class today or you want to be solving this on your own. Otherwise, listening to me. Remember, listening to me doesn't teach nearly as well as you trying it and then seeing how well you did. Seeing how well you did with me talking over it after you've tried is far more valuable in learning. Okay, so let's see it. Price at $15, 800 copies. So price at $15, we can sell 800 copies. So let's go ahead and plot that because we know that's going to be a question. And then if the book is priced at $20, so the book is priced higher, then we can only sell 550 copies. Because, right, if you sell something for more money, fewer people are going to buy it. So this makes sense. So at 20, copies, $20, we can sell 550 copies. Okay. So now we've plotted both of them on both points on the graph. Happy cat for that problem. Assume the relationship between the number of books sold and the price is linear. In other words, assume that the graph is a straight line. So let's draw a line that passes through these 2 points. Now I'm going to stop. Watch what I do. I'm going to stop here. Now, one thing that isn't pointed out, and hopefully your teacher pointed it out, and I'll certainly point it out to you, but because what you did here is you broke the graph, there's an implied break in the graph all the way up. Because you broke the graph here. This is not 15. Normally a graph would go 15, 14, 13. It would be a nice even bend, but you jump from 0 to 15 here, and these are all 1. These are all 1. These are all 1. These are all 1. But this one here is 15, and that's, you know, you have broken the graph. So you cannot extend the line. You cannot extend the line across a break in the graph. Okay, so we cannot do that. We have to stop here. Let's just put this nice red stop sign. We have to stop right here. Okay. If you need any more explanation on that, you can ask your teacher, or you can send me a note on YouTube. But you cannot extend. It would be incorrect to draw this line here and say that this is our y-intercept. Can't do that. Okay. So now we know that 15, 800, but we can draw a straight line here because there's no breaks. There's no breaks down here. So we're good to go from that perspective. Okay, what is the rate of change relating to the number of copies sold to price? Well, we don't know what the slope is. The rate of change, and again, you know, that's another word for slope. And that's, I'm going to give you a hint. It's delta y over delta x, and that's equal to y2 minus y1 over x2 minus x1. And we can calculate that. Why? Because we have 2 points. We have this point and this point, which is the same as this point and this point, these 2 ordered pairs. So let's find our change in y over our change in x. Our change in y is 550 minus 800 over 20 minus 15. Why did I take the small one minus the big one? Because this is our second point, and this is our first point. So we have to take our y's, our y2 minus y1. Our y2 is the smaller number, and here our x2 minus x1. That's the bigger minus the smaller. So we have negative 250 over 5, which is equal to negative 50. And what are our units? Our units, remember, our slope units our slope units is equal to our y units over our x units. Again, been doing this for 2 whole modules, many lessons. So our y unit is copies sold per day over the price. So that's copies per dollar, or copies per price in dollars. So if for every, so that's our slope units, copies per price in dollars. So if we raise the price $1, we sell 50 fewer copies per day. So again, if we want to sell at $15, we can sell 800. If we sell 16, we can only sell 750. We sell 50 less. And if we sell it for 17, $1 more, it's 50 copies less, 50 copies less, 50 copies less for every additional dollar. Okay, so based on the graph, if the company prices the book at $18, how many books do I think I can sell? Well, I think I can sell, what, 650 books, which makes sense because I can sell 800 for 15, 550 for 20. So if 18, I'm in between. And so 650 is what the graph is telling me and what makes sense. Good. Let's lay down our happy cats. All right. Based on the graph, approximately what price should the company charge if we want to sell 700 copies? All right. So we go over here and look at 700 copies, and we want to see how many we want to sell, or what price. Well, that price is $17. And there you have it. Representations of a line. These are 3 great word problems that that they came up with in the book. And again, hopefully you don't feel cheated or anything because I didn't come up with new examples or new problems. I just feel that today's lesson was so important and the examples were so good. I wanted to explain using those examples. Tomorrow and beyond, we will likely go back to me using my own examples. But today's lesson, I thought, again, really good. So hopefully you learned something today. Moving on to lesson 4 tomorrow. We have 11 more lessons, and then we're done with the year. So congratulations for hanging with me, and we'll see you next time.